Okay, I think we are live. I'm sorry, guys. We are slightly late. We were setting up a few things, and it took us some time. I'm sorry for that. So yeah, welcome to Cracku again. Today we'll be covering circles. I hope that you are consistent with your preparation and watching all the live sessions. Today we'll be doing circles. A few days back we covered triangles and progressions and all. Also, there's not a lot of time left for your exam. The exam is in next month only, so you should be fully focused at this time, and you should be wholeheartedly preparing for the exam. Also, happy Children's Day to all of you. I wish that you all have a very happy and prosperous career. With that, we'll start. So yeah, today we'll be covering circles. Circles is one of the important topic within geometry. We covered triangles. Further, we'll be covering more important topics of geometry and of other topics also. So we'll go through a schedule first. This is the schedule. Right now we are doing circles. We had done a number system yesterday. We also covered triangles, mixture, functions. Further, we will be covering PNC. PNC is going to be an important topic, and we are very sure that it is going to be tested in the exam, because if you see the curriculum is more towards statistic side, and PNC becomes an important topic there. So you should be very focused, and you must cover this session. Further, we have a webinar on Sunday where you can join and you can ask all your doubts related to the program, related to your preparation. If you have any issues you are facing, or if you are not sure how to prepare in this last leg, you can ask all your doubts live with the mentor. Further, we will be covering quadrilaterals next. So all the sessions are packed. You should be consistent with the preparation. I would suggest you guys to not miss out on not miss out on even any session. Join all the sessions. Understand the concepts. For that, further, we have something more for you. That is, we have 5 free IIM B UG program based mock test. We thought a lot about what IIM Bangalore can test, and based on that we designed the mocks. All the mocks are free. We have designed 5 mocks, and you can appear for these exams you can appear for these mocks anytime. You all you need to do is go to Google, search Cracku IIM B UG mock test. The first link you will get mostly will be of the same page. You can appear for the mocks, and this is the right time, and this is the time when you should be starting appearing for mocks, because the exam is in next month only, and you have to get accustomed to sitting for 2 hours focused and solving the exam in proper exam setting. So for you to get understanding of the environment, exam pressure, mocks are proper simulator. You have weekends coming. Tomorrow is Saturday, then Sunday. 2 days are ideal. I would suggest you guys to take at least 1 mock each day. Just see how it goes. Understand where you are good at. See where you are lacking, and then start preparing accordingly. Also, we have complete playlist. We have complete program free for you. Just go to Google, search Cracku IIM B UG playlist. You will get the link. You'll get the mostly it will be the first link only on the web page. Go there and see. We have added all the important concepts playlist and important videos. You can appear them, and you can watch all the videos, make your notes. Also, if you have any further doubt, we have created a WhatsApp group. You can find the link to join the same in the description. Whenever you have any doubts or anything, you can ask that in that group. Also, there is one more important update, that IIM Bangalore will be conducting a free webinar where it will be clearing all the doubts of the students. It will be tomorrow, and the time is 2 to 3. It is there on their website. You can go to the website or go to this particular page on this link, and you can join the webinar. You can ask all your doubts there. Yeah, and for that and further, we have this WhatsApp group as we discussed just now. Whenever you have any doubts and all, you can ask your doubts in the group, and we will be putting all the important updates in the group only. So it is good that you join, and you should be completely free from any further updates. If there will be any other update, we'll be putting that into group, and you will be notified this way. So yeah, with that, we'll start the session. Okay, first thing, the topic circle is something we have been covering in our earlier classes only, but after a point of time, and especially from the perspective of a competitive exam, the exam really tests your application of your understanding, how well you understand the concept, and if you can apply the concept well or not. For that, we will be covering all the things from the basic, and we'll be doing some questions also, where you will be applying whatever we will be learning today. Basic thing, we'll be covering basic terms first. So first, obviously, what is radius? If you notice, yeah, for any circle, there is a center, which is the middlemost point. This point is equidistant from any point on the circumference. From any point on the circumference, this point is equidistant or equal. And this is exactly called radius. If you join the middlemost point, that is called center, and to any point on the circumference, that is called a radius. There can be numerous radius or uncountable radius in a circle, because there can be multiple points or uncountable points on the circumference. So you can join and create multiple radiuses. Second, we have diameter. It is basically extension of radius. If you join 2 points on the circumference which are passing through the center. For example, there are 2 points. Let's say first point is here, another point is here, and this is passing through the center. Then if you notice, this part is nothing but a radius, and further this part is also a radius. So if you extend a radius and join it to the circumference on the other side, it will become a diameter. Then we have chord. The simple definition of chord is if you join 2 points on the circumference. Circumference is nothing but the perimeter. This part is called the circumference. I hope that this is something you already know. Okay, so chord is when you join 2 points on the circumference. It can be any 2 points. From here you can join any 2 points. This is one chord, this is another chord, this is another chord. So if you join any 2 points on the circumference of the center, on circumference of the circle, you get a chord. Then we have an arc. Arc is basically some part of the circumference. For example, let's say if we have this circle, if I take out this part, so this part will become this will be called a arc. Now if you take out one arc, there will be 2 parts. If you have, for example, this is one circle. If you have taken out one part, there will be another part also. So the smaller part or smaller arc is called a minor arc, and the bigger part or bigger perimeter or bigger circumference or a bigger arc will be called the major arc. So this will be called a major arc, and this will be called a minor arc. You can judge this by looking only. If it is smaller, it is minor, and otherwise it is a major one. Then we have a segment. Segment is nothing but if you join 2 points on the circumference, or if you basically make a chord, then the circle is divided into 2 parts. For example, I have this circle, I make a chord, or basically I join 2 points on the circumference. Then it makes 2 parts. This is one part and this is another part. So this part is called segments. Whenever a chord divides the circle into 2 parts, they are called segments. and again they have two segments. One is minor segment, because that is smaller one, and another one is called major segment. Then we have covered these. Then we have sector. Basically, if you want to take out some part of the circle, you either take it out by joining 2 points or by using chord, or you can take out some part using radius. How can you take out some part of the circle using radius? By making two radius. Now if you have joined two radiuses, then this part and this part, they become two parts. Similarly, like so basically you can understand that you can join a chord to make two parts, or you can use two radiuses to make two parts of the circle. Again in the circle, so these two parts will be called sector. This is one sector and this is another sector. Again this is a major one, so it will be called major sector, and this will be called a minor sector. One more thing, so one second, this will be a minor sector. So yeah, if you make a chord, then you get two parts, that will be called segment, and if you join two radiuses, that will make sectors. Okay, then we have tangent and secant. Now this is something that is new to you. You might not have heard this or studied this in your school. So tangent is nothing but if there is a line which is passing through a circle but not intersecting it, it is just touching it externally, then it will be called a tangent. For example, this line. This line is not intersecting the circle, it is just touching it on the outside. So this will be called a tangent. Opposite to this is secant. It also passes through the circle, but it intersects at 2 points. So it is this will become a secant because it is intersecting at 2 points. This will be called secant. So tangent which does not intersect, secant which intersect at 2 points. So these are the important things. We'll move on now. Most of these things are very basic. Now, formula of the there are some formula related to circles. First is, if you want to find out the area, you know that there is a circle and it has a radius. If you want to find out the area, how much area does this circle covers, then we have a direct formula for that, that is pi into r square. Now the value of pi is 22/7, which is constant, or sometimes you can refer this as 3.14. Similarly, we have, if you want to find out the circumference, or if you want to basically find out the length of the, or you basically want to find out the perimeter. Basically, if you start from this point, if you cover the whole circle and then come back to the same point, then how much distance you have covered, that will be called the perimeter or circumference. For that also we have a direct formula, that is 2 pi r, that is twice of 22/7 into r refers to radius in both the cases. Radius will mostly be given when you are asked area and circumference, but these are very simple questions. Okay, so you have covered area, you have covered circumference. Now if someone asks you the length of the arc, again arc is if there is a circle and you take out some portion of it. If you take out some portion of it, then if you are asked how much length it is, for that all you need to do is you need to find a ratio of how much angle it makes at the center. We know that whole circle is equal to 360 degree, and if you take out only this part, then this will be making a particular angle at the center. It will be making an angle at the center. So if you find out that angle, and you find out the ratio, you can find out the circumference of the arc or length of the arc. Basically, out of 360 degree or out of 360 degree, how much angle you are taking. So you will be making a ratio out of 360 degree. Then you can multiply the same with the circumference of the circle. Similarly, you can find out the area also by finding out the same ratio. Now, let's say if I say find out the area of a sector whose radius is 14 and it is subtending an angle of 60 degree at the center. We need to find the area of sector. So we have the circle, there is center, we need to find the area of the sector which is making an angle of 60 degree at the center. So let's say if this is one angle, this is one radius, this is another radius, this is 60 degree, and we need to find the area of this sector. All you need to do is out of the whole area of the circle, what part is this? For that you are calculating basically what is the ratio of this 60 degree out of this whole 360 degree. So out of whole 360 degree, you need to find the area of only 60 degree. This is the ratio, and then you multiply this ratio with the area of the sector because that is your finding. So that is pi into r square, that is 14 square. This is nothing but 1 by 6. With that you get that this portion is 1/6 of this whole portion, and that is something you are calculating out of the whole area. Of the whole area you are finding the area of only 1/6 part, and this 1/6 part you found using the angle the radius is making at the center, or basically angle the sector is making at the center. This way you can find out the length of the arc as well as area of the sector using the angle. Okay, now when you come hi, good evening Anna, good evening Arnav. Okay, next, after that we have there are some important properties of chords. So these are basically important properties, and they are mostly directly applied when you are asked something like triangle inside the circle and all. It's important that you know all these basic properties. First, the perpendicular drawn from the center of a circle to a chord bisects the chord. What does this mean? Basically, if you have a circle and there is a chord and there is a center, it says that if you draw a perpendicular from the center to the circle, of the circle to the chord, from the center you are drawing a perpendicular on the chord, then this perpendicular bisects the chord. It will divide this chord into two equal parts. So if you draw a perpendicular from center to the chord, that perpendicular will divide the chord into two equal parts. It's not necessarily that it is this way only. If you do it this way also, let's say our chord is here. If you are drawing a perpendicular here, again it will divide the chord into two equal parts. Conversely refers to vice versa. It means opposite also. That is, if a line from the center is dividing the chord into two equal parts, that means it is a perpendicular. The line joining the midpoint of this chord and the center of the circle, if there is a line that is joining the midpoint of the chord, let's say here, and the center, then this will be nothing but perpendicular only. So vice versa, if you draw any line from the center to the chord, it will divide into two equal parts, and if a line is making two parts or two equal parts of a chord, or dividing the chord into two equal parts, it will definitely be perpendicular. So this is the first one. Let's say this is refers to perpendicular property. Second, chords that are equidistant from the center of the circle. So if there are two chords, and if we say that the chords are equal, then they have to be equally distant from the center. They can't be at the same place. That is, again, if there is a circle, if I say that there is one chord and there is another chord, here is the center. Now if I say that both the chords are at the equal distance from the center, that is the distance from the center till here, that is, let's say, x, and this is also x. It means this chord, let's say chord 1, and this chord 2, the length of these two chords is equal. That so if the two chords are equal, the distance is basically you are making a vice versa also, because we have conversely here also. You can do it either way. If the two chords are equal, they will be equidistant, and if two chords are equidistant, they have to be equal. If the length of the perpendiculars from the center of the circle to the two chords are equal, the chords are also equal. So that is second property. Third, the length of a chord increases as it moves closer to the center of the circle. Now it is very intuitive that, let's say we have a circle, here is one chord. If you move to the circle, then the length of the chord will increase. This one is longer than the previous one. As you move closer to the circle, then the length of the chord will increase. And this way, the longest chord of a circle is nothing but diameter, because that is the maximum point. After that, it will again start reducing. So we can say diameter is equal to longest chord. Now how does it change? It is very intuitive that if the chord is farthest, okay, or at a longer distance from the center, then the angle it will be creating will be smaller. As it gets close to the center, let's say here, then the angle it will be subtending will be higher, and the wider the angle will be, the length of the chord will also be wider. Look, for example, let's say here there are two circles, they are the center. Let's say there is one chord. If you make an angle here and there is another chord here, if you make an angle here, you can clearly notice this angle and this angle. This angle is smaller than this angle. So when the angle is smaller, the length will not be that wider, so it will create a short chord. But if the angle is wider, it will create a longer chord. So this way, this is very intuitive. You can easily understand this. Lastly, equal chords subtend equal angle at the center. Let's say I have this circle. Okay, this is one chord, and I make a equal chord here. Both the length of both the chords are equal. Then I can say that both the chords will be subtending equal angle at the center. So if this chord make this angle at the center, let's say this is called theta, then this chord, second chord, this chord will also be making theta only. Let's say this is C1 and C2. We say that C1 is equal to C2, then they will be making equal angle at the center. So these are the four common properties about chords. Yeah, we'll move on now. I think this would be clear. Next we have we have two theorems. First we have inscribed angle theorem. It says that if there is if there is a chord, or if there is an arc which is making an angle at the center, that angle will be half of if the same arc or chord make another angle at the vertex. That is, let's say we have this chord, or you can assume this arc only. Okay, this chord or arc make particular angle at the center. Now if same chord makes another angle at the circumference, at any point on the circumference, that angle will be half of the angle that is subtended at the center, or basically the angle subtended at the vertex or at the circumference will the angle subtended at the center will be double of the angle subtended at the circumference. So this will be 2 theta. Let's understand one more. If we have a circle and we have a particular chord or let's say arc, and they are making an angle at the center. Now that angle will be twice of the angle made by the same chord at any point on the circumference. So if they make theta angle on the circumference, they will make twice of that theta angle at the center. Let's read. It says that the angle inscribed by 2 points lying on the circle at the center of the circle, this will be twice of the angle subscribed by the same points at any point on the circle. Let's understand with the example also. So let's say this is A and B, they are making particular angle and they are making another angle at the circumference. So this angle will be twice of this angle. This would be simple, I guess. Next we have angle subtended. Okay, it says that angle subtended by the same segment of on the circle are equal. Let's say we have a chord. Let's say we have a chord and there is any angle made by this chord at the circumference will be equal at any number of points. For example, this chord make an angle here. This chord make also an angle here. This chord makes also an angle here. Then all these angles will be equal. So we can say that if there is a chord and it makes multiple angles at the circumference, then all these angles will be equal. It says that angles subtended by the same segment is created by chord on the circle are equal. Here we have this. Okay. Here we have, let's say, this chord. Okay. This is making an angle here. Making an angle here. They can make an angle here also. At any point on the circumference, they will be equal. I hope this is clear. And last we have angle subtended by the diameter of the circumference is right angle triangle. Right angle. This is very, very important. And it is going to be directly applied a lot of times. This says that the third point, it says that if there is a diameter and that diameter subtend any angle at the circumference, then that will definitely be a right angle triangle. Let's say this diagonal makes an angle here, then this angle will be 90 degree. If the same diameter makes angle anywhere on the circumference, that will be 90 degree. So if there is a diameter and diameter subtends an angle at the circumference, that will be 90 degree. Angle subtended by the diameter of the circumference is a right angle. There will be a lot of times you will be mentioned that okay, one side of the triangle is diameter. Then you quickly understand if one side is diameter, it means it is definitely a right angle triangle. Okay, we'll move on now. Further we discussed tangent in the first slide. What is tangent? Tangent is nothing but a line passing through the center, touching it externally and not intersecting it. There are a few properties related to it. First one, two tangents drawn from the same external point to a circle are equal in length. That is, if there is one point, there is one circle, and if two tangents are drawn from the same point on the circle, let's say this is one tangent and this is another tangent. Let's say this is called P, this is Q, this is R. Then the length of these two tangents will be equal. if one point, if two tangents are created from the same point, same external point on the circle, then the length of both tangents are equal. This is simple only. Then we have tangent secant theorem. Now understand this, and this is also important. That is tangent secant theorem. Tangent secant theorem. Now what does this mean? Or what does this theorem says that? This theorem says that there is a relation between tangent and secant. Let's say there is one tangent from point, okay, let's say here. Let's say this point is x. From this point to x, y, there is one tangent. Let's make a secant also. We know that secant intersect the circle at 2 points. Let's say these points are A and B. So tangent secant theorem says that the square of the length of this tangent, that is xy square, this will be equal to xa into xb. Or product. That says that if we have a tangent and a secant on the same circle from the same point, then the length of the tangent will be equal to external part of the secant and the whole secant. External part will be x2a into the whole secant, that is x2b. Now let's do some more calculation here. If from the same point I make another secant, let's say this is called P and Q, and from the same secant also I can say if xy square will be equal to the same external part, that is xp into x2q. I can say the same because this secant is also from the same point, so it will also satisfy the same equation. Now if the left hand side is equal, the right hand side will also be equal, that is xa into xb will be equal to xp into xq, that is x2a into x2bq, x2p into x2q will be equal to x2a into x2b. So this is one part and this is second part. These two things you need to understand in tangent secant theorem. It is not difficult, just understand the concept, understand that okay, what is the relation, and you are good to go. Third thing, we have alternate segment theorem. Alternate segment theorem also applies when there is a tangent. Alternate segment theorem says that, let's say I make a tangent and there is a chord on that on the point of the point at which the circle and tangent meets. Let's say this is the circle, this is the tangent, and there is a chord. For one end of that chord is at the point where tangent and the circle meets, and it is making an angle with the tangent. This chord is making an angle, let's say theta, with the tangent. Then that angle will be equal to if the same chord makes an angle in the another segment. This is one segment, the another segment will be this segment. If the same chords make an angle in the another segment, that is why it is called alternate segment, then this angle will be equal to this angle. Let's do it other way also. Let's say if this is the circle, this is the tangent, and this is the chord. Now if this chord is making an angle, let's say alpha, to this side, which is in this side of the segment. Now if the same chord makes the an angle on the alternate segment, that is this segment, then this angle will be equal to this angle. So whenever you have a chord, a tangent and a circle, and chord is making an angle with the tangent, that angle will be equal to, if the same chord makes an angle in the alternate segment, this angle is equal to this angle and this angle is equal to another angle in the alternate segment, then they will be equal. This is a very useful property, and a lot of times you might not know okay how to proceed, but you will realize that okay, there is a direct property or direct theorem is being applied here, that is alternate segment theorem. Just understand that if a chord is making an angle with the tangent, you quickly remember about angles alternate segment theorem. These are the three important properties related to tangents. Next we have, so this is one of a specific type of quadrilateral, that is if there is a quadrilateral within the circle. Let's say there is a circle and there is a quadrilateral inside the circle. So it is a unique type and it has some specific properties, and also we'll study that. First thing, a very important property of a cyclic quadrilateral. Whenever there is a quadrilateral inside a circle, it can be rectangle, square or anything. You always remember that the sum of the opposite angles is equal to 180 degree. This angle and this angle, the sum of these two angles will be equal to 180 degree. Let's say this is angle A, this is angle B. So angle A plus angle B is equal to 180 degree. Similarly, this angle C, let's say, and this is angle D, angle C plus angle D will be equal to 180 degree. So sum of the opposite angles in a cyclic quadrilateral will be equal to 180 degree. They are supplementary. Supplementary is nothing but if two angles sum up to be 180 degree, those are called supplementary angles. There is one more term to this, that is complementary. If two angles sum up to be 90 degree, that will be called complementary. Now how to find the area of such kind of quadrilateral? Now if you know all the four sides, you can find out the area of this kind of quadrilateral. Let's say the sides are A, B, C and D. Then the first thing you will find is S. S is nothing but S is semi-perimeter. That is half of the perimeter of this quadrilateral. The perimeter will be sum of all the sides and you need to divide it with 2. This will be S, that is semi-perimeter, and we have a direct formula for that, that is under root or square root of S minus A, that is side A should be subtracted from the semi-perimeter. Similarly, side B should be subtracted. Similarly, C and D, and the product of the outcomes. Square root of that will be equal to the area of the cyclic quadrilateral. Remember, this is only applicable in cyclic quadrilateral and not anywhere else. This is similar to Heron's formula, but don't get it confused. It has 4 sides and it is not multiplied S also as we multiply in Heron's formula. So this is all about, this is major important things about circle. We covered tangents, we covered important formulas, we covered important properties of chord. They are very important. We covered cyclic quadrilateral. Further, we will do some questions based on circles only. The first question we have is this. Pretty simple question based on direct formula. Do this. Alright, I think a lot of you would be able to do this. It was simple question only. It says that we need to find the area of the region part. If you notice, it is nothing but you need to find the area of the bigger circle, and from that you need to subtract the half of this smaller circle. What is the okay? What is the area? What is the formula for the area of a circle? That is pi r square. This is equal to area. So first we'll find out the area of the bigger circle. The radius of the bigger circle is from here, let's take another color, from this point to this point. It is not visible, okay, blue. From this point till this point, it is equal to 7, and the additional is 3.5 meter. So the length of the whole bigger circle is 7 plus 3.5, 10.5 meter. So the area of the circle, of the bigger circle, is pi into radius. 10.5 is nothing but, if you notice, it is 21 by 2. So radius is equal to 21 by 2. So area will be 21 by 2 square. That is 21 square is 441. Pi times 2 is nothing but 4. This is the area of the bigger circle. From that you need to subtract the area of this smaller circle. That is this part. The radius of this is 7 meter. If the area of the whole circle is pi r square, if you divide it with 2, you will get the area of the half circle. So we can find out this, that is pi times r square. R we already know, that is 7 square, and we need to divide it with 2, because we are calculating the half area only. That will be 7 square is 49, pi times divide by 2. From the whole area we need to subtract this, 441 pi divided by 4 minus 49 pi divided by 2. We can take pi common. This will be 441 divided by 4 minus 49 divided by 2. If we multiply 2 on the both sides, we can get the denominator common. If we multiply 2 here, it will be 4, so common, and this will be 49 into 2, 98. This is basic LCM only. If you subtract this, this will be 343 divided by 4. We are asked the direct information. We are not given the value of pi, so we'll do the whole calculation. The value of pi is nothing but 22 by 7 into 343 divided by 4. Now this is cube of 7. So if we cancel, this will be 49. This can also be cancelled. This will be 11 and 2. So it is 49 into 11 divided by 2. This will be 490 and 49, which is 539 divided by 2. And if we divide this, this is 540, that is 270, and 0.0 subtract, it will be 269.5 meter square if you cancel this out, or if you find out the absolute value. So the answer has to be option B. It was simple question. There was some calculation, but if you have a calculator in the exam, you use that, find out the value easily. You had the whole circle. From that you need to, from the area of that circle, you need to subtract some smaller portion. We'll move on. We'll do the next question. This is the next question. Again, slight easy question only. Yeah. All right. I think it was an easy question only. It says that uh, the total area of two circles touching each other externally. So there are two circles which are touching each other externally. Here, okay. The area of both the circles is the sum of the area of both the circles is 365 pi centimeter square. If the difference of radii of two circles is 1, basically the difference of the radius is only 1. If we assume that the radius of this circle is, let's say, a, then the next the radius of the another circle will be a plus 1. Fine. What is the radius of the larger circle? Basically, we need to find the value of a. If let's assume that the radius of the first circle is a, the area will be pi a square. Similarly, if the radius of the second circle or the larger circle is a plus 1, then the area will be pi times a plus 1 whole square. And we are given the sum, that is, if we join them, this will be equal to 365. It looks like we will be getting a quadratic equation because we have a square here and a plus 1 whole square here. All we need to do is we need to find the value of a, because then we can find out the area of radius of the larger circle. Okay. Now, if we solve this, this is pi times 365. If we can take out pi from both the sides and we can cancel that out, so we'll get 365 is equal to a square plus a plus 1 whole square. We can cancel out pi on the both sides. We have a square plus a plus 1 whole square can be solved using a square plus b square plus twice of a and b. This simple formula I think you would have studied in your school only. This is commonly applied. So we'll apply the same here, that is a square plus square of the second term, 1 square will be 1 only, plus twice of first term and second term, which is twice of a. This is equal to 365. Solving further, we have 365 is equal to a square will be twice of a square plus 1 plus twice of a. Now we can take out this value to the other side. We'll get twice of a square plus twice of a plus 1. When the value goes to the other side, the sign changes. So it is positive 365, it will be negative 365, and that will be equal to 0. We have again a square plus 2a. If we solve this, this will be negative 364, that will be equal to 0. On the left hand side, we have 2, which is common to all. So we can take that out and it won't impact our quadratic equation if there is a common multiple to all the terms. If we take out 2, it will be a square plus a minus, taking out 2 from here, it will be 182 is equal to 0. If we take this 2 to the other side, it won't matter. We can divide 2 to both sides. So we have this quadratic equation. Now I hope that you know how to solve a quadratic equation. We need to find two numbers, the multiple of whom is 182 and the difference between them is 1, that is coefficient of a. Those two numbers are 13 and 14. So we can write this quadratic equation as positive 14a minus 13a and minus 182. This is equal to 0. We can take out a common from here. It will be a plus 14. We can take out 13 common and negative sign also common. This will be a plus 14 is equal to 0. Or the quadratic equation we get is a minus 13 and a plus 14 is equal to 0. So the value for a we get here is, from here we get 13 and from here we get minus 14. But since we know that the a is nothing but radius and radius cannot be negative, so the value of a has to be equal to 13. So if the radius of this circle is 13, another circle will be 14 because the difference between them is 1 only. So we are asked that what is the radius of the larger circle. Larger among them is this one, and the radius of that circle is 14 centimeters. So the answer has to be option E. Now we'll move on to the next question. Okay. It is an interesting question. It is something related to we did the day before yesterday related to equilateral triangles. Try to use that also. Okay. Before we start doing this question, I want to explain a concept that is related to square. Although we will be covering quadrilaterals, but beforehand only I'll just explain a small thing. Let's say if we have a square, we know that all the sides of a square are equal. Then we can assume that, let's say this side is x and this side is also x. So the diagonal will be this. Yes. So the diagonal will be this. Now we also know that all the angles of a square are equal, and that is 90 degree. So this angle is equal to 90 degree. With that we can apply Pythagoras theorem to this triangle, and we can calculate the length of the diagonal. Let's say the diagonal is d. So we can say that x square plus x square is equal to d square. X square plus x square is equal to d square. That is twice of x square is equal to d square. Or if we take square to both sides, it will be under root of twice x square is equal to d, or d is nothing but root 2 of x. That is, this is nothing but root 2 of x. So what do I mean? It means that if we are given the side of a rectangle, if you are given the side of a square, then the diagonal of that square is nothing but root 2 times of the length of the side. So if you are given the length is, let's say 10, then the length of the side square is at 10. Then the length of the diagonal will be root 2 10. So if you know the sides, you can directly calculate the diagonal of that square. So here in this question we have, it says that a square is inscribed inside a circle of radius r. Let's say this is a circle, there is a square inside it. Now you know that if I join 2 points on the circle and passing through center, that will be a diameter. So these this will be the center, and if I am joining this point, this will be a diameter. We are given that the radius is r, so this is r and this is also r. So if we assume, we can take out this rectangle, this triangle outside. Further it says that an equilateral triangle circumscribes the circle. There is an equilateral triangle outside this circle. Okay, it will be something of this form. We'll make it more simpler here. Okay, this and this. Okay, this is an equilateral triangle. Now we are asked what is the ratio of the length of the side of the triangle and the side of the square. In both that we have a circle in common. There is a square inside the circle and there is circle inside the rectangle, inside the equilateral triangle. We can calculate both, we can represent both, that is side of the square in terms of the radius, and we can also represent side of the equilateral triangle in terms of the radius, and then we can find out the ratio. We'll do both the things separately. First thing we have is there is a square inside the circle. We know that this is diameter, and with that we can find out the and we know that this is r and this is r. With this we can find out the side, because if let's say this is the triangle, this part, let's say the side is x and it is x, and the diagonal is twice of r. Now we just did that. If you are given the side, the diagonal is √2 times of the side. So if the side is x, then diagonal will be equal to √2x, and √2x is given as twice of r, or we can say x is nothing but twice of r divided by √2, or x can be mentioned as √2r. How? Because √2 is nothing but √2 into √2. So here I can write 2 as √2 into r divided by √2, and this can cancel out, so I will be left with this value. With this we found out that if the diagonal is 2r, then the side will be √2r. This will also be √2r. With that we have find out the side of the square in terms of radius. Similarly, we can find out the side of the equilateral triangle in terms of radius. We have, let's say, this circle, this equilateral triangle and this circle. Let's say the length of the side of the equilateral triangle is L. We know that this is R, and in the class day before yesterday we covered that if you know the length of the equilateral triangle, you can find out the in radius, that is the radius of the circle which is inside the triangle. That is, if you know the length of the equilateral triangle is L, then height of that equilateral triangle will be √3 divided by 2 into L. This will be length of this equilateral triangle. L refers if there is side. We have assumed that this side is L. So height of this equilateral triangle is √3 divided by 2 into L, and this in radius is nothing but 1/3 of this. That is √3 divided by 2 into L into 1/3. This is equal to in radius, that is radius of the circle inside this triangle, and the radius is given as r. In that we can find out the value of L in terms of r. We can take out these values to the other side. We have r into 3 into 2, 6 divided by √3. Okay. Now 6 can be written as, we can write this r into 6 can be written as √3 into √3 into 2, because this will become 3 3 into 2 will be 6. Divide by root 3, and root 3 and root 3 can cancel out. So length, or the length of the side of the equilateral triangle, will be twice of root 3 of radius. We have found this. We have found the side of the equilateral triangle in terms of radius. We have found the side of the square also in terms of radius. We are asked the ratio of the length of the side of the triangle to that of the square. For triangle, it is twice of root 3 divided by r divided by root 2 r. R and r can cancel out. Further, again, r I can 2 I can represent as root 2 into root 2 into root 3. This is as it is. 2 can be written as root 2 into root 2 divided by root 2. This can cancel out. This value root 2 into root 2 will be root 2 into root 3 will be root 6 divided by 1. So the ratio will be root 6 divided by 1, which is option number B. All we did is we know the radius only. So we calculated the side of the square in terms of radius using diagonal. Similarly, we calculated the side of the equilateral triangle using radius, because we know if we know the height, then in radius is 1/3. For the students who might not know, you can go through the session that we covered, that we did the day before yesterday of triangles. In that we covered that in depth, how the in radius can be calculated if you are given the equilateral triangle. We'll do next question now. I hope this would be clear. Okay, it is an easy question. I hope you would be able to do this. Alright, so it says that if a wire of length A is made into a circle, okay, so with wire you created a circle, and then an equilateral triangle is made with the equal length of the wire. The same length can also be used to make a equilateral triangle, and the same can be used to make a circle. It means that the perimeter of the circle is equal to the perimeter of the equilateral triangle. We can equate them. Let's say we have circle and the radius of this circle is r, and we have an equilateral triangle. Let's say the side of this equilateral triangle is s. We are told that perimeter of this and perimeter of this is equal, because same wire, having same length, can be used to make both. So we can equate the perimeters. Perimeter of circle will be equal to perimeter of equilateral triangle. Now perimeter of circle is nothing but circumference only, and that is equal to 2 pi r equal to perimeter of equilateral triangle. Perimeter of equilateral triangle is nothing but sum of all the sides, and all the sides are equal. Let's say one side is s, all the other side will be s only, so perimeter will be nothing but 3s only. Okay, now we are asked that find the ratio of the areas of circle to that of the triangle. We need to find the ratio. For that we need to know the ratio of their side and their and the radius. So what we can do is we can find out the ratio. Let's say r is here, we can take s here, and 3 is here, we can take this 2 pi to the other side. So this will be 2 pi. With this we got this relation. The ratio of radius to the side of the equilateral triangle is equal to 3 divided by 2 pi. So if I assume that radius is 3x, then side of the perimeter, that is s, will be 2 pi times x. We have got this relation. Now all we need to do is we need to find the areas and put them into the ratios, because now we have this common relation between them, that is their ratios. So we need to find the area of the circle. Area of the circle is nothing but pi r square, that is equal to pi times radius square. Radius is 3x square, 3x whole square. 3 square is 9, x square is x square, so x pi times 9 pi times x square. This is the area of circle. Further we need to find the area of triangle also, that is area of equilateral triangle. Now in one of the earlier classes, the day before yesterday only, we understood how you can easily and direct find out the area of the equilateral triangle if you know the side. There is a direct straightforward formula for that, that is root 3 by 4 side square. We know the side, so we can find out the area also, that is root 3 divided by 4 into side square. Side is 2 pi x whole square, that is root 3 divided by 4 into 2 square is 4, that is we have pi square, and then x square. 4 and 4 can cancel out, so we have root 3 times pi square and then x square. We need to find the ratio of their areas, ratio of the area of the circle to that of the triangle. The area of the circle is 9 pi x square divided by the ratio of the area, the area of the triangle is root 3 times pi square into x square. X square and x square will cancel out. Pi can cancel out one of the pi, and then we have 9 times root 3 pi. Now 9 can be written as 3 into 3, and same 3 can be written as root 3 into root 3, because root 3 and root 3 is nothing but root 3 square, and square root can cancel out. So I can write 9 as root 3 into root 3 into 3 in 3 divided by root 3 pi times. Root 3 and root 3 can cancel out. So here we have root 3 root 3 divided by pi. This is the final ratio we get. Let's see which options has this. So it is option D, 3 root 3 divided by pi. This is the ratio we get. This was an easy question, finding a relation between two different figures. If we are given some information about them, here we are told that both are having same perimeter. It can also ask if both are having same area, then you can find the relation between the side using between the side of the equilateral triangle and radius using area, and then again do the same to find the ratio of their side and radius. Most of such questions are solved using their ratios. You find the ratios, take up some variable, the variable at the end mostly cancels out, so you get a final ratio. we'll move on. We'll do next question. Yeah, this is an interesting question. It applies one of the concepts that we did today. I hope that you are able to identify the concept. It is very important. I'm sorry guys, I forgot to turn the timer. Oh yeah, it is started. I'm sorry. Okay. Now it says that two circles of radii 15 units and 20 units intersect each other such that the distance between the centers is 25 centimeter. Let's say the two circles are, this is one circle and there is another circle, and they are intersecting each other. So we have, let's say this is another circle. Yeah, so we have one here, we have another center here. The distance between the center is 25 centimeter. Now we are said that the radii are 15 units and 20 units. So this, let's say the radii for this circle is 15 units and for this it is 20 units. So if we assume that this is nothing but, if you notice that this will be nothing but a tangent, and I told that or maybe we would have missed this, that a tangent, if there is a radius that is coming at the point of the touch of the tangent and circle, then it will be perpendicular. That is, if we have this tangent and there is a radius coming up, it will be perpendicular. So we can say that this will be nothing but 90 degree. And similarly, this is also making another angle. So this will also be 90 degree. So this way, this is nothing but a 90 degree this will make a triangle of 90 degree. So if we take this out, we have this. This is 90 degree. We are directly given this is 25 and this is 15 and this is 20. Now we are asked that the length of the common chord. If we notice, okay, and this. The common chord between these two circles is when you join the two intersecting circles. These two circles. That is, if I join the same this way, they will be meeting somewhere here. This is the common chord between these two centers, between these two points of intersection. The length, we need to find the length of this point. Okay, now just assume that you are understanding only the take part, only the half of the part. If you find out the length of this, you can double it to find out the length of the whole chord. If you assume only this value, this is 90 degree, 15, this is 20 and this is 25. The area of this triangle will be what? We can find out the area of triangle in multiple ways. We covered this. One of the ways, half time base into height. And because this is a right angle triangle, the area will be half time base is, you can assume 15 and 20 anything and height the other thing. So the area will be 150. Similarly, if you drop a perpendicular from this point, this. Similarly, this will be a perpendicular and this will be base. So the area has to be equal to half times this base 25 into this perpendicular. Let's say this is h only, height. This should be the area, and we already know the area, that is equal to 150. If you take 2 to the other side, this will be 1500. 150 into twice divided by 25. So h will be nothing but let me confirm if there is any issue. $150, half of this is 150, half of this will be 1 by 25 into 2, 300 divided by 25. Okay, yeah, it is clear only. 25 divided by 6, this will be 6 and it will be 16 into 2, 12. So this height, half of the height is nothing but 12. If this is 12, this is also 12. So this whole will be equal to what? 24. Similarly, here we had this was 15, this was 20 and this whole we know it's 25. So we calculated this half side from here till here. We calculated this to be 12 and another part will be also same, that is 12. So this whole length of common chord will be 12 plus 12, which will be 24 centimeter. That is option D. Only thing you understand, you need to understand is, if there is a circle, there is a tangent and there is a radius on the point, then they will be perpendicular. Radius will be perpendicular on the tangent. Or basically you can remember this concept, radius will also be always be perpendicular on the tangent. Yeah, so we'll do the next question. Okay, it is also an easy question. I mean, you need to just understand one concept here. Where can point be? If you can understand that, or if you can make the cases, it will be easy for you to solve this question. Make sure that you don't forget to include the concept of where can the point be. Okay. Uh, I hope that you would be able to guess, okay, what this question is trying to test. It basically wants to test that if you are able to figure out where the point can be. It says that if the shortest distance of a given point to a given circle is 4 centimeter, okay, shortest distance is shortest distance is 4 centimeter and the longest distance is 9 centimeter. So what can be the radius of the circle? Now assume that we have a circle and the point can be at 2 points. It can be inside the circle or outside the circle. So if we assume that if the point is outside the circle, so the shortest distance will be from this point to the nearest point in a straight line. This will be 4 centimeter. And if it is outside, the longest distance will be if from the same point it goes to the last point, and it has to be the longest chord, which is equal to diameter. Diameter is the longest chord, then it will make a longest distance. We are given the longest distance, so we'll assume that it is passing through from this point till this point. It has to be a diameter. So this will be whole from here till here, it will be 9 centimeter. So if this is 4 centimeter, this will be equal to what? 5 centimeter. And if diameter is 5 centimeter, the radius will be half of it, which is 2.5 and 2.5. With this way, if the center is outside, if the point is outside, then the radius will be 2.5. Now let's take another case where the point is inside. It is also again easy. If let's say point is anywhere inside, the shortest distance will be 4 centimeters. So if I drop any shortest distance to the nearest point on the circumference will be 4 centimeter. The longest distance will be if I stretch the same point to the another side, but it has to pass through center, because only then it will make a longest distance. So let's say if the center is somewhere here and it passes through this, then from here till here it will be another longest distance. This will be 9 centimeter. In that case, when point is inside, shortest distance will be this, longest distance will be further, and it is passing through center. Then from here till here it is nothing but diameter, and diameter will be 4 plus 9. 4 plus 9, this will be equal to what? 13 centimeter. And if diameter is 13 centimeter, the radius will be half of this, which is 6.5 centimeter. So this kind of situation can have two radiuses. One, if the point is outside, then the radius will be 2.5, and if the point is inside, then the radius will be 6.5. So the answer has to be option D. Always in such kind of question, and try to understand that, okay, what can be the situation. Try to make a graph and see what can be the all possibilities. Here we were not given the possibility, we were not given, or we were not specified exactly where the point is. So you have to consider all the possibilities, especially if you find the question which has options like or. So try to just guess, okay, if it is saying or, it means there can be multiple possibility, and then try to understand, okay, what can be those cases. Further, we'll do the last question of the day. It is again based on circle. Yeah, it is an interesting question. I hope that you will be able to solve this. This question tests your three concepts that we have covered in this week. We covered progressions. We covered one of the things we covered today only, that is related to diagonal, square, and then area of the, basically the relation between square and circle. Try to solve this. Alright. It says that the square is inscribed in a circle with diameter 10 centimeter. Now whenever there is a square inside in a circle, understand the concept that we did in I think last to last question, that is, if let's say this is the circle, there is a square, then diagonal of that square will be equal to diameter, and if you know the side, if the side is x, then diagonal will be equal to root 2 of that side. We'll use the same concept here. We are given there is a square inside that circle and diameter is given as 10. That is, this diameter or basically diagonal is given as 10 only. If we compare root 2 x, this is equal to diameter and diameter is 10. With this we can find out the value of x, that is side of the square. This will be equal to 10 divided by root 2. Or if we solve further, this will be nothing but, okay, we can expand this, or basically we can simplify this by 2 into 5 divided by root 2, and 2 is nothing but root 2 into root 2. So we can write this as root 2 into root 2 divided by into 5 divided by root 2. This can cancel out, or we get the side is 5 root 2. This is the side we have got for this square by comparing just the diameter and diagonal. Okay. Now it says that a circle is then inscribed in the square. So within this square, there is a circle inscribed. Okay. We know the side of this square, that is 5 root 2. Now we just did that if side is x, then the diagonal will be root 2 of that x. So this is also 5 root 2. That is diameter. Okay. Now it says that another square is inscribed in the second circle. Within this circle there is another square. Okay. And this will be then diagonal of that square. We know that the diagonal of this square is nothing but side of the square, because within the square, if there is a circle, if this is the side, let me explain clearly. If this is the square and there is a square, there is a circle inside that square, then the diagonal of that square will be equal to length of the side. So we can say that within this square, let me take another color. Within this circle, sorry, this is the diagonal, and diagonal is nothing but 5 root 2 only, because this is diagonal, this is also diagonal. So this will be equal to 5 root 2. Yeah, this is equal to 5 root 2. Again, for this smaller square, we know the length is 5 root 2. Then the radius will be what? Let's say radius is x, radius is y. This, sorry, not radius. The side is y. This is also y. Then diagonal is root 2 times of y, which is given as 5 root 2. If we cancel out root 2 and 2, we get y is equal to 5. So the side of this square is 5, or this is equal to 5. The side of the previous square was this. The side of this square is 5. Okay. This is, let's say, square 1. This is, let's say, square 2. This will be 5. We are said that this process will go on till infinity. That is, in the circle there is a square. Within that square there is a circle. Within that circle there is a square, and this will keep on going. Up till a point it will be very negligible. I mean, you can't even see it from your normal eyes. It will keep on going on. Okay. What is the value of the sum of areas of all the square? We need to find the sum of the area of all the square. Let's find out the area of the first square. That is 5. The side of that square is 5 root 2. We know that area is nothing but side square. So side square will be 5 root 2 square. That will be 5 square is 25. Root 2 square is 2. 25 into 2 will be 50. So the area of the first square is 50. Let's find out the area of the second square. If the side is 5, area will be side square, 5 square, which is 25. So area of first square is 50. Area of second square is 25. You notice that area gets half. Similarly, for the next square, if you solve this, the area will be further half, which is 12.5. And this will go on till infinity. And you need to find out the sum of the areas. Now remember the concept in progression that we studied. If there is a geometric progression till infinity, then there is a direct formula to find out the sum of the terms of that geometric to that infinity terms. That is, if in geometric progression the common ratio is less than 1 and greater than -1. Here our area is getting half. So the common ratio is 1/2. In all such cases, the sum of all the term is nothing but a divided by 1 minus r. I hope that you remember we did this in the session. A is nothing but the first term and r is nothing but the common ratio. Then a, that is the first term, is 50 divided by 1 minus r, which is 1/2. This will be equal to 50 divided by 1 minus 1/2 is 1/2. This will be equal to 50. Whenever there is a denominator within denominator, it goes to numerator. So 50 into 2 will be 100. So the sum of all the areas of all the squares will be equal to 100. Till here we use the concept of circle and square. After that we understood that okay, this will create a series, and this is a specific type of series which is when the common ratio is between 1 and -1, and we have a direct formula to calculate the sum of the terms. You realize that how the concept of different topics can be used in other topics. The concept of progression used in geometry, and this way that is why it is important for you to understand all the concept and memorize them, and you should know how you can apply that. If you don't know, if you would have not have known this progression, then you would have been continuously doing this manually, which would have taken a lot of time of yours. To simplify them only, we use this geometric progression. So I would suggest you guys to don't miss out on any topic. Understand the concept of all the topics, attend all the live sessions that we are doing, ask your doubts, join the watch the playlist that we have on our website, search Cracku IIMB UG complete playlist, you will get the link, and also appear for a mocks and try to apply your knowledge, apply the concepts that you have learned so far. For this, the answer of the question is 100 centimeter square. So this was the last question. Today we did circles, we understood tangents, properties of chords, cyclic quadrilateral. Further we will be having, tomorrow we will be having the session on permutation combination, very important topic. Now again the same concept will be applied, permutation combination can be applied in number system, and it is actually applied a lot of time. So if you know permutation combination, you can solve some of the question of number system very quickly. So I would suggest you guys to attend all the live sessions. Again, last, don't miss out on mocks. You have weekends, attend the free mocks. I would suggest you guys to at least attempt one mock this weekend on each day and see where do you stand. The students are actually attempting these mocks. You can see what are the score of other guys, okay, where they stand, where do you stand, in what section you need to improve, what kind of questions that can come in the exam, and how to tackle them in the exam pressure, in the exam setting. Lastly, we have our WhatsApp group. I would suggest you guys to join the group so that you can get all the updates timely. We are putting all the notifications, any update that comes up as soon as possible. So if you join the WhatsApp group, it will be free. So you will be free that, okay, you will get all the important notification from one single source, and you can also ask your doubts there. With that, we can end the session. I wish you guys good luck.